All right, hopefully we can stay awake long enough to get through this problem. It's very similar to the last one. You just have to know how to factor. And I know you guys know how to factor, and I know that you guys remember the first thing you do when you factor. You got to factor out the greatest common factor.
No.
Oh my God.
You don't? You didn't remember that?
No.
Yeah, but you got burned on your test too because you didn't know that. So when I look in the numerator, that's the top. Take out the GCF. Make it pop. And what?
You're funny.
Yeah, the looks aren't everything. In the numerator, what's the greatest common factor?
3x what?
Oh, you can do better than that. Come on now.
3x squared.
How about you do 6x squared?
X squared.
You take out a 3, you're going to have an 8 and a 6 left over, which isn't good enough.
Top and bottom. Sorry.
Yeah, I thought you were saying it.
Oh, no. I'm talking, we're just do this guy for right now. How do you factor him?
4x.
You take out the 6x squared, and what are you left with?
4x minus 3.
Okay, in the denominator, what's the GCF?
3x to the 3x cubed.
X.
3x to the third, and what are you left with?
5x plus
7.
5x plus 7. Now, I'm going to rewrite this to help you guys out here in just a second. But if you look at this, 4x minus 3 and the 5x plus 7, is there anything else I can do with that?
No.
No. These guys aren't common, so they don't cancel, like I had in the last problem. But 6x squared and 3x to the third, if I mean, this is multiplication, right? If I had just this, could you simplify that fraction?
Yes.
Yeah, how could you simplify it?
By 3.
So what would you have?
It'd be
It'd be 2 over 1, but the x is on the
X,
bottom.
It would be 2, and you have more x's in the bottom by 1, so it's 2 over x, right? Now, to help you see that, I'm going to write out the factors here. 6 is 2 times 3, and you have 2 factors of x. And in your denominator, you have just a factor of 3, but then you have 3 factors of x. So you can see that when I start canceling things out, the pair of 3's will cancel, a pair of x's, and another pair of x's. So, in my final answer, you see that in the numerator, all that's remaining is a factor of 2 in the 4x minus 3, what's in the denominator? X and then 5x plus 7. Do you all agree?
Yes.
Okay. Questions about that one?
So that's it?
There's nothing else you can do there. You need to understand in the numerator, Angie, you just have 2 factors. You have the number 2, and you have the factor 4x minus 3. And in the denominator, the factors are x and 5x plus 7. There are no 2 factors that are exactly the same that I can cancel. Well, because I know that you guys love to factor and make a bunch of crinkly noises right next to the microphone. Let's try 2x squared minus 5x plus 2 all over 4x squared minus 1. To do these problems, you must know how to factor. If you can't, very bad test coming up. So, you always look for the GCF first. Do you have a common factor in the numerator?
No.
No, it's a trinomial, 3 terms, so I expect it to factor as the product of 2 binomials. How does it factor? I mean, what do you have to do when you break down 2x squared? You don't really have a choice.
Just the x. 2x cubed.
It's got to be 2x and x, and what do you know about your signs? You have to multiply, get a positive too.
So it's negative, negative.
Both are negative, but 2 is a prime number, so you have to use what?
1 and 2.
Can I put the 2 here?
No.
Nope. 2 goes here, 1 goes here. Does that work out? Negative 1x, negative 4x gives me the negative 5x. Good. What about that denominator?
2x plus 1, 2x minus 1.
My head is getting heavy.
You're 2x plus 1, 2x minus 1 is the difference of squares. I told you I love the difference of squares. Then what do I do?
The x minus 2 over 2x plus 1.
So the 2x minus 1's cancel, right? And then I'm left with x minus 2 over 2x plus 1. There's nothing else you can do. Don't try to cancel these 2's because they're not factors, they're just terms, right? And that's all I can do here. Questions about this? Do you see that what I'm basically doing here is I've got two factoring problems. Like what you would have had on your test, you would have had two separate problems, right? I'm just putting both these guys in a fraction. I'm asking you to factor both of them. And if you can reduce like you reduced with fractions before, you do that now. So there's nothing too new from what we were doing before. It's combining fractions and factoring.